extra mercury in there. So, other heavy metals or minerals that are going to cause problem: aluminum. Probably heard of people heard that aluminum isn't great to drink from. Aluminum's in cans. Also in antiperspirants or deodorants, they put aluminum in there. Some people cook with it. Also found in vaccinations. Fluoride. When mice were fed small amounts of fluoride, they went hyperactive. So fluoride is a neurotoxin found in drinking water and toothpaste. Anybody know why we put fluoride or where fluoride came from, or why we started using fluoride?
Tooth decay.
Tooth decay. That's what they told us. Where it came from, it started coming from when we started developing atomic bombs. They use fluoride to enrich uranium, and so it's a byproduct of enriching uranium. But they were able to get the dentist to agree that fluoride would potentially help with teeth. Whether or not that's true is definitely a controversy, but we're not going to talk about that tonight. The study that we were concerned with more is this fluoride fed to mice and the hyperactive. So, anybody remember this hit? Reggie Bush got cleaned up. This is just showing the impact. So if you have this E4 gene, you're going to be more susceptible to head traumas. So that's why I said maybe you want to get your kids checked, because if they have that gene and they're playing sports, the more impacts that they take, they have an increased chance for having brain trauma. When we get damage from a brain trauma, we still need those genes to help clean up some of the damage that's in there. Brain can only survive 3 to 5 minutes without oxygen, so it's important that we're getting enough oxygen to the brain. That's why when we have things like a stroke or a heart problem, we got to make sure we get oxygen going into the system right away, otherwise we have the potential of getting brain damage. And we can recover from some of that. We're only using a small percentage of our brain, so we can actually train our brain to use different parts and to recover from some of those things, as long as we can get oxygen in there in a certain period of time. So we can relearn how to do a lot of different things. Glucose is the food for the brain, and so we don't have like a big storage cell of glucose in the brain. We only store a small amount, so it's important that we're constantly getting blood and sugar to the brain in order to keep the brain working well. If we don't get blood sugar going to the brain's going to shut down. So that's why it's important to eat breakfast in the morning, so we can get some blood sugar going in there, so we can get the brain turned on. Now, sugar is actually a very important thing, because we know we need sugar for the brain, but we also know that sugar isn't necessarily a good thing for the brain. Anybody had like a candy bar and then like, I don't know, an hour later, half an hour later, you kind of feel tired, you're groggy, you get the initial rush, and then later you kind of feel like you got the brain fog. So what happens here is we get a big spike of blood sugar. Sugar goes into the brain, and then our body releases insulin to try to control that blood sugar levels. So a lot of cells in the body have like a cell membrane around them, so that only so much sugar can get in, but not nerve cells. If we don't control how much sugar is in the body, sugar just keeps going into the nerve cell, and it's like if you just keep blowing up a balloon, eventually the balloon will pop. The same thing happens if you keep putting sugar inside of a nerve cell, eventually the nerve cell gets damaged. So with people that have diabetes, we see nerve problems with their hands and their feet. So as nerves get too much sugar that get into them, it causes problems, but it also causes problems in the brain. So too much sugar is bad, too low of sugar is bad. We want to keep that sugar level balanced. So how do we do that? Eat vegetables and fruits. Proteins from nuts. So vegetables are low glycemic index, means your body doesn't cause a huge blood sugar spike. They're loaded with antioxidants that help to bind to some of those heavy metals and some of those toxins that we're bringing in, and help to stabilize blood sugar.
Any kind of nut, or
well, there are certain nuts that are better. So walnuts are better, almonds are better, filberts,
pecans,
peanuts. What do you guys think? Do those count? No. Now, peanuts don't count. Not technically a nut. They're more of a legume, which is like a bean. So don't eat peanuts and think that you're going to get some benefits. They help to decrease our cravings, so we're not going to have a big sugar craving. What about diet stuff? Think this stuff is good or bad for your brain?
Poison.
Yeah, it's bad for your brain. So this stuff is chemical, not designed to be put into the body, not designed for our body to be able to eliminate. So if we have that E2 gene, more likely you have a good chance of getting some of this stuff out of the body. If you have the E4 gene, less chance that we're going to get this stuff out of the body. Lots and lots and lots of stories of people having different neurological type of problems with these different types of aspartame.
What about the new stevia stuff?
Stevia is actually different. Stevia is an actual plant versus an artificial thing. So it's actually something that grows in the ground, and our body has a much better chance of being able to deal with stevia.
Okay.
You're going to hear some controversial things about stevia because, believe it or not, the people that make aspartame, they don't really like stevia.
Right. Yeah.
They're kind of competing, so they kind of have the market share right now, so they have the money, so they can put out different opinions about how stevia works. But it's more natural, it's going to be a safer option.
They have a new thing called Truvia, but it's, once again, they've modified stevia to be Truvia. Don't buy it.
Oh, they're not the same thing?
No.
I thought it was just a brand name of stevia.
No.
Yeah, so stevia is a much safer option.
Yes.
So when we get damage from those artificial things, or whether it's from the environment, or pesticides, or different things we're putting into our body, basically what happens to, how does this affect our brain? How does this chemicals affect our brain? We have to detoxify the chemicals. If we don't get the toxins out, they damage the brain directly. The toxins go in and cause direct nerve damage. But what they also do is they get into our digestive system and they start to cause damage throughout the digestive system. And so in our digestive system, we normally have small little openings that only let in certain digested proteins into the body. As we start to take in more and more of these chemicals, these openings start to get bigger and bigger. So instead of having to digest the protein to get it into the bloodstream, some of these bigger proteins now start to move into the bloodstream without having to get digested and broken down. That's where you're going to see a lot of the autoimmune diseases coming from. Brain injuries and brain problems are part of an autoimmune type of a thing. So if we don't get the chemicals out of there, we start to get these big proteins moving into the bloodstream. When the blood sees these proteins in there, it sees them as not normal. They're not supposed to be there, so it's going to start to attack them and sees them as a foreign invader. So we start to make antibodies, which I call little Pac-Man cells, or little airplanes shooting things down. These antibodies are going to go out and they're going to try to destroy these proteins. Problem is, let's say we're eating wheat, and the protein from the wheat, our body sees that as a foreign product. Now every time we eat wheat, we're going to go and we're going to make an antibody to wheat, the gluten, the protein that's in wheat. Not a problem initially, but a lot of our cells have that broken down protein as part of it. So as the body sees this wheat protein, it wants to go out and attack the wheat protein, but it's also going to start to attack some of our own body cells that have that same wheat protein makeup. They look very similar, so our body starts to attack itself. Thus, auto or self-immune, the immune system is attacking itself. So we start to get antibodies that attack themselves, and this can happen with the brain and the nervous system too. So if you've heard of MS, that's where your body's attacking its own nerves, the lining that goes around the nerve, that's where your body's attacking in that situation. If you've heard of, what's another one, diabetes, the body can attack itself, or thyroid disease, the body can attack its own thyroid. So those are just a couple of examples, but it can also attack its own brain. So they've actually come up with tests now to test to see what your body's attacking itself for. So they do these antibody tests, and they have one that they can measure to see, are you building antibodies against your own brain? So the nice part is you could actually do this test and you can find out 10 to 20 years in advance that your body's making these antibodies, that it's attacking its own brain, and you can figure out what's causing that and stop that from happening. Once we start to actually see brain damage because of this, or thyroid damage because of this, the damage has already been done, and now we're scrambling at the last second. So the time to know this information is going to be ahead of time. Gluten is one of the most common offenders. Most people think of gluten as just a digestive issue, but it's actually only 1 out of 5 or 1 out of 8 people that have a gluten insensitive that actually have a digestive problem. A lot more people have like brain problems or joint problems, and it's because of the gluten. Dairy is often associated with brain fog, so I don't know if you've ever eaten ice cream or had a big glass of milk and you kind of feel like you're just a little bit cloudy afterwards. That would mean that you might have a food allergy to dairy. Very, very common with this brain fog or can't quite think clearly type of a thing. A lot of people that get headaches, then it's actually coming from some type of a food allergy. But the headache is actually where your body potentially is attacking its own brain. Blood test and skin test is not always reliable. The elimination diet is the best test. So you want to eliminate whatever the food is that you're going to test out of the diet for about a month, put it back in, see if the symptoms start coming up. So if you notice at lunch,